Now, as you may have guessed looking at the notes, aldol condensation is kind of a big idea. And I don't mean big in a complicated idea, I mean big in just a hard to work with idea. There are two major hurdles with aldol condensation. First of all, predicting the products. Second, reverse engineering what it took to get you to those products. So, chemical synthesis. Conceptually though, what's going on is not that bad. So let's start this long series on aldol condensations off with just kind of discussing what's really going on with aldol condensation. So for aldol condensation, what we need are two ketones, each containing an alpha carbon with a hydrogen so they can undergo this tautomerization. Now for simplicity here, I'm going to stick to ones that are symmetric. So it's the same ketone reacting with itself. And let's let one of them undergo tautomerization. Now I'm going to run this under basic conditions. This would be true under acidic conditions, but it's just going to kind of make the work chemistry a little bit easier to see. So let's let the blue one undergo base catalyzed tautomerization to give us the enolate ion. Well, let's look for the positive and negative. And your expectation may be, well, here's the negative, it's going to attract the carbonyl, and we're going to end up getting basically an oxygen attack. You're going to get an ester. Actually, that's not what happens. What we end up getting is that when we retautomerize, this double bond here is going to attack the carbonyl carbon, and it's going to bump up that double bond up here to give us a lone pair. What we end up forming, so this is going to be this carbon, it's this, and oops. The ketone with an associated alkoxide. Now, again, when our base abstracts, it can leave a hydrogen. We can get this hydrogen back. And what we can end up with after this is all said and done with is an alcohol. So, what just happened? Under basic, but this can occur under acidic conditions as well, we end up creating the enol, or the enolate. This enol is going to attack the other ketone at the carbonyl carbon to form a carbon-carbon bond. These are much more stable, which is why it wants to form it. This will result in forming a ketone with an OH group and alcohol on the what would be considered now the beta carbon from our starting ketone.